Hello everybody, good morning, good afternoon or good evening, depending on where you are in this lovely world. Welcome to this Trials and Tribulations of Process Risk Assessment webinar for the next 45 minutes or so. Just as way of introduction, I'm Andy Fowler. You can see there, currently Technical and Operations Director for Sigma-HSE. My background, I'm a chemist by training, 10 plus years in chemical manufacturing on major hazard sites, doing lots of things, putting new processes in and so on and so forth. 17 years in the UK's Health and Safety Executive as a process safety specialist and risk assessor. And then the previous 13, 14 years in consultancy, primarily with process safety, all elements of process safety, including a lot of risk assessment work. So getting on now for close to 40 years knowledge and experience in this subject of process safety. So hopefully I can pass on some interesting views on this topic this afternoon. And as you know, working for Sigma-HSE, we're a process safety consultancy and also a testing house. So we are capable of doing the raft of testing for powders, liquids, vapors, fire explosion testing, as well as chemical reaction hazard assessments. So not only can we provide the consultancy, but also the testing, or turn it round another way, interpret those testing results for you and help discuss the impacts of that on your design. You can see we've got a global presence, primarily in India and in the UK, and the sorts of things that we cover. So let's get started then, I think, on the trials and tribulations of process risk assessment, because it's a very interesting topic. And as you'll be aware, just by listening to the news constantly these days, especially with the COVID situation, we'll hear this term risk bandied around quite frequently, almost every day. But do we really understand what that risk means? So in this webinar today, what I'd like to take you through is to try and get you thinking really about how does my business, your sites, how do they manage process safety risk assessment? Is it done properly? And in fact, how should it be done properly? So of course, the primary focus of the things I'll be trying to develop today in my discussion are around, obviously, you know, one of the basic things is we're supposed to be in continuous improvement mode when we're doing risk. Within the UK, and indeed most of Europe, the health and safety system is a risk-based goal-setting approach. It's not very prescriptive, i.e., if you've got a problem, there's very little you can do to decide whether or not what you have to do to solve that problem. Yeah, in terms of all we have to do is follow these rules. There's an element of that, but what the legislation is trying to do is remove us from that of simply having a checklist of if we do this, then the risk is low enough, and that's all that matters. We're supposed to be, as in every aspect of a business, in continuous improvement mode, striving constantly to make things better. And that doesn't matter whether we're talking about health and safety or whether we're talking about any other core aspect of a business, because we know that if we don't continually improve our processes, our management systems, our products, then eventually our business will die. We need to keep changing. And this is difficult, of course, because as humans, we tend not to like change. Change is something that constantly happens to us, but many of us would rather not have change and just stay with the way we've always done it. And the other key focus will be on, this subject of risk assessment. it isn't just calculating the risk. It's making a decision at the end of it. It's deciding, have we done enough? Have we done everything that we should have done? And because we're in this goal-setting mode, of course, with there's certain ways in which we can go about calculating our level of risk and making these decisions, generally based on cost-benefit analysis. Again, the same is true whether it's health and safety we're talking about, or quality, or productivity, or whatever. And, you know, what do we do within our businesses from doing the proper job? And this is a big element, I feel, where risk assessment is, in a sense, flawed. And it's because of the cultural things we do within our business to stop us from doing the proper job. So let's just remind ourselves just what we're trying to do under this subject of process safety management. And it's essentially answering these questions, understanding what can go wrong, what bad events, fires, explosions, toxic releases, and so on, can we have on our sites and the impact of that. And then, of course, we'll put things into our process designs to reduce the level of likelihood of these bad things from happening. And then our day-to-day job is making sure that those items of equipment primarily, or tasks that we do, provide us with that necessary risk reduction only if those measures are effective. And that's where most of you in your day-to-day lives, whether you're operating a process, operating it correctly, whether you're maintaining a process and everything else, is associated with making sure that these protective measures are effective. But our risk assessments really focus at the forefront, that first question, do we really understand what can go wrong? And that's where there's a big emphasis on hazard identifications through HAZOP or LOPA or these sorts of things, and then trying to look at what measures we've got installed to manage that hazard and reduce the level of risk down to a level that we're happy with, everybody's happy with. We're happy as a business, the regulator's happy, and in a sense, society's happy as well, that we've got things under control and we're not having these incidents that potentially could cause us harm. And that harm may be harming people or harming the environment or indeed harming the business. So let's just remind ourselves what risk is. Risk is a function of the consequences of a hazard and the likelihood of those consequences occurring. Okay, it's a simple thing like this, and really to be able to evaluate or calculate the level of risk, generally speaking, is a pretty simple thing to do. If you can count and you can divide, then you can calculate the level of risk. And I've just given a little example here. So if we take the COVID situation over the past year in the UK, the COVID-19 has killed around 120,000 people, and that's out of a population of 66 million. So, you know, simply by counting the number of harms and dividing those by the population that's at risk, we can calculate the risk of death to humans in the UK from COVID-19 as that simple division. And the risk comes out at 1.8 times 10 to the minus 3 per year. And that's how you'd normally see risk. Statements like that is how you normally hear about risk. The risk of killing an employee on one of your sites from some dangerous substance is 1 in 100,000 per year, or this sort of thing. That's how we'll calculate things. Yeah. So given that we've calculated that the risk of death to humans in the UK is this value of 1.8 times 10 to the minus 3, and in a sense that's a fact, because we've counted the number of dead, we know the population. So over the year 2019 or 2020, there's nothing wrong with that, and it's statistically meaningful because we're only talking statistics really here, and we've got a large population size and a relatively large impact or harm. Okay, but the question is, remember I said at the start, risk is a decision-making process, risk assessment. So obviously, once we've calculated the level of risk, we've got to ask ourselves, is this level of risk too high, or is it okay? Do we need to do anything, or do we not need to do anything? Now, within the UK, and indeed in many areas of the world, things called risk tolerability criteria have been developed to help us make that decision, so we can calculate the level of risk and then we can compare that with these criteria. So in the UK, and this is very similar across many areas of the world, it was considered that the risk of death of a worker from work activities is too high if it's greater than 1 in 1,000 per year. The risk is known as intolerable. And in the legislative framework in the UK, that means if we've got a risk that is too high, essentially we must reduce that level of risk, irrespective of cost. If we go back to a slide or two earlier, we calculated the risk of death from COVID in the UK as 1.8 times 10 to the minus 3. So it's higher than this intolerable level for a worker. And of course you can say, yes, but many of those people, it's very age dependent, so you can play figures on those levels of risk, okay? But there's also criteria set for the risk of death to a member of the public from work activities, and that's set at 1 in 10,000 per year. So you can see we've exceeded these criteria. We're basically saying that if COVID was a working situation, that level of risk would be too high and we'd be doing lots about it. We'd be making decisions on the basis of that. Now, the difficulty is that when we're doing risk in normal life, where we're just having to count and divide and we've got large populations, everything's fine really. It's easy to do. It's looking back, of course, because all we're doing is calculating the level of the harm against the population. When we're considering process safety incidents or health and safety incidents, we don't necessarily have that history where the same event has happened. So the level of risk, like when we're calculating the risk of death from COVID-19, or we could calculate the risk of death from driving a car or from eating too much fatty food or anything else, we can do that because we're looking at one single event, which is statistically significant because we've got a large population size and we've got a large amount of harm. In the industrial situation, especially when we're looking at fires, explosions, toxic releases, unless we work on generic factors, we don't have the same event happening the same. We don't have workers being killed by exactly the same event. So it is a lot more difficult to calculate the level of risk then. But it's something the health and safety law requires us to do. In fact, health and safety law doesn't actually require us to calculate the level of risk, but it does require us to carry out a risk assessment. It becomes more difficult because we don't have this single event. When we're looking at process safety risk, we need to take a large number of events and calculate the level of risk from those larger number of events. So for instance, if I've got a tank of a dangerous substance, then that tank can release its contents in various ways, from catastrophic failure all the way down to a corrosion leak in the tank. The consequences from each of these events will be different, and the likelihoods will be different. The likelihood of catastrophic release from a vessel and a corrosion hole are quite dramatically different. It's a lot more unlikely that a tank will catastrophically fail than it is that we get a small leak in it. And of course, a tank's not much use on its own, so it's got pipes coming in and out of it generally, otherwise it's not very useful. And of course, we can break those pipes in a different way, either from guillotine failure or, you know, leaks from flanges or corrosion holes and everything else. And then we might be filling road tankers, so of course the tanker filling hose can release its contents and so on. So what you'll find is when we do process safety risk, we identify a lot more hazardous situations or events, and we calculate the risk to a whole group of them. Because we're not looking back historically, we have to do this. Otherwise, because we can get it wrong in a big way. So for instance, I may calculate that the risk of a certain release from a tank could kill somebody at a rate of 1 in 100,000 per year. We can calculate that, and it'd be quite a reasonable calculation. But if your plant's only been there for 50 years and that event happens tomorrow, then it becomes a 1 in 50 year event. That's not strictly true, but I don't want to get into the detail of that. But for illustrative purposes, just to illustrate, we can get it wrong in a big way for each individual scenario. So what we need to do is take a range of scenarios and calculate them in the same way. Okay. This just illustrates that there is another further criteria set in the UK at 1 in a million per year, the broadly acceptable level. Yeah. Now, one of the problems with risk is if we look at the risk of scenarios and calculate them, there is a tendency to use these criteria as target levels, and that's not what they're meant to be. So you may even for an event that has a broadly acceptable level of risk, it's called broadly acceptable for a reason, because there may be things you could reasonably do to make the situation even better, to reduce that risk even more than what it is. But, you know, very often when we do risk analyses, it's been the practice over the years to say, well, this event is at 1 in a million or close to, therefore we're not going to think about it anymore. Okay. So to try and focus on these range of products, what the risk practitioner will do when they're calculating the level of risk will be to try and fix what I call the 3 whats of risk analysis. Risk of what, from what, and to what. So the risk of what could be risk of death. It could be risk of injury. It could in fact be risk of something called a dangerous dose or whatever. Okay, so there's different of whats. Risk from what? Well, that could be from all serious events on site, or from events in that are to do with chlorine or some other dangerous substance. And then risk to what? Well, this could be risk to humans, or we can differentiate that further and say risk to employees, workers, or risks to members of the public, or risks to the environment, or risk to the business. You know, we could even do risk to the boss's cat if we wanted. It's all calculable. Yeah. And what you'll find is the risk practitioner will tend to try and fix the 3 whats. And what we tend to do in process safety is we do 3 risk analyses really. We tend to focus on the risk of death to employees. We'll do another calculation on the risk of death to members of the public, and then we'll do a separate assessment on the risk of harming the environment. Okay, but again, the output from all of this are phrases of the type: the risk of killing an employee is 1 in 100,000 per year. That's the risk statement from this sort of analysis. Okay, so when we take our range of events and we apply the 3 watts, that's important because that gives us a list of events which we can put in risk order. We know which event is the one with the highest level of risk and the order all the way down to the event that's got the least level of risk. And this is important because this then can be used to focus our minds. Yeah, we should be focusing on those events that give us the greatest level of risk. We can do an awful lot because the total risk for a site is in a sense simply the summation of the risks of all of the scenarios that you've come up with when you've identified your hazardous situations. So clearly those with a higher level of risk are going to dominate the total level of risk of the site. So improving those events that are already at low risk will have very little impact on the overall risk for the site. Yeah, if I put it simply, if I had out of 10 events, if I had 2 events that were approaching 1 in 1,000 per year events, and the other 8 were approaching 1 in 1,000,000 per year events, then my total risk for the site is going to be dominated. It's going to be around the 1 in 1,000 per year. Only if I try and focus and reduce the risk on those 2 highest events will I have an impact on the total risk for the site. But that's the risk analysis. And then there's a 4th what. So we've calculated the level of risk, and the 4th what is, well, so what? I've just told you that the risk of killing one of your employees is 1 in 100,000 per year. Well, so what? Is that too high? Is it okay? Do I need to do something? Do I not need to do anything? So we move then into a decision-making process. Are we going to do something? Or is there anything we can do to reduce the level of risk? We're making a decision. And that's the difference between a risk analysis and a risk assessment. It's a decision. And of course, that decision can change. And the tool to help us make that decision is our cost-benefit analysis, where we look at what else we could do to reduce the risk, what practically we could do, and then see if it's worth doing in terms of cost, trouble, and so on and so forth. And if the cost far outweighs the benefit that you get, then under the UK law, we don't need to install that benefit, that additional risk measure. So that's the sort of approach to it. So if we just focus now, what stops us doing this properly? Now, undoubtedly, within your business, within your given site, you'll have your health and safety management system or a process safety management system, which will be loaded up with policies and procedures. And you'll have many procedures for actually calculating the level of risk. You'll have procedures for identifying the hazards, which may be HAZOP or HAZOP, for example. You may have procedures for actually how you do a LOPA, which is one type of risk assessment, or a quantified risk assessment, or whatever. And that's fine, but these are just specific risk assessment tools. They only undertake that risk analysis. So we've got to have some basis on making our decisions. I've given you one basis, what the law is in the UK in terms of those risk tolerability criteria, and in many businesses have set their own risk tolerance criteria. They have, of course, in the UK, if you set your own risk tolerances, they need to be lower than the level of risk that the regulator has published. But there could be better, and many companies that I've worked with assume that the intolerable level for risk to a worker is actually set the same as the criteria for a member of the public. So it's one in 10,000 per year rather than 1 in 1,000 per year. But that's fine. There's nothing wrong with that. That helps us make our decision. But there's lots of things that go on within a business that stop us from doing the right thing, stop us from making those good decisions. And one of the primary reasons for this is that there is no policy set by the business on how do we determine the level of risk and make that decision that that level of risk is sound and acceptable to everybody, and that's our aim within the business. Good policies are light on the how. The specific procedures you have, this is the procedure for doing a HAZOP, this is a procedure for doing a LOPA, are very much what I call how documents. They tell you how to apply that tool, how to carry out a LOPA or a HAZOP. Yeah. Whereas a good policy, which sets the direction, raises the awareness, sets the standard. A good policy is focused on what I call the 5 W's. It looks at who, what, when, where, and very importantly, why. Yeah. And these will be different, they'll be loaded up. This policy will be loaded up of the different tools and techniques that you use for calculating levels of risk and making decisions. But it'll make it clear who's accountable, what is expected to happen, when these things are expected to happen, and give you some reason to make you aware of the bigger holistic picture of why are we doing these sorts of things. And as I say, in my experience, very often this risk policy is missing, this thing that ties it all together. And process safety management has to be looked at holistically. We can't be in silo mentality. We can't just, well, I'm only interested in doing the HAZOP, and it's somebody else's problem to take the bigger picture and make the decisions. But the output from all of these tools is a good understanding of what can go wrong, and then the items of equipment and the special tasks that we employ within the business to reduce the level of that consequence from occurring. That's what we're trying to do. Now, there are some basic tenets of risk assessment, and this is where many businesses fall foul, if you like. Risk assessment should be used in a positive way. We shouldn't be using risk assessment to not do something. It's not the philosophy of risk assessment is to do something positive, to make this change, to reduce the level of risk. If it's acceptable to do so, if it's reasonable to do so, that it should be proportionate. We don't want to be doing HAZOPs and LOPAs and things if we're looking at very low levels of hazard. Where the hazards are high and the risks are high, we need to employ the most appropriate techniques and so on. And all of these techniques we require lots of resource, people with knowledge and understanding in very robust, methodical tools that we use. They take up a lot of resource. There's a lot of effort that's needed, which of course is costly effort. but the aim is always trying to reduce the level of risk. But there is a golden rule, and in the UK it's not really written down within the law, but it exists. And there's a golden rule that you're supposed to apply before you go anywhere near risk assessment, really. And that golden rule is that you comply with current accepted good practice guidance. And this is normally written down, doesn't have to be, could be custom and practice within a sector. And it can be in different forms, whether that's regulations all the way down to guidance. And that sets the minimum requirements. And of course, that accepted good practice will change as time goes on. So although your plant was designed and built 30 years ago, it might look different today if we were building it today, if we were complying with this golden rule of looking for current accepted good practice. For example, not too long ago, it was accepted good practice if you were storing chlorine to have the bulk storage tank in the open air. That's no longer considered accepted good practice. It will be in a building with scrubbers and ventilation and so on and so forth. The standards change over time. So we've got the golden rule, and if you comply with the current accepted good practice, in many instances, that's all you need to do. In a sense, groups of people have got together and decided what's necessary to safely store or handle this type of material and written it down. And in many instances, especially if that hazard doesn't go beyond the site boundary, then compliance with the current accepted good practice may be all you need to do. The risk assessment process comes in to make sure that you don't need additional things on top of the requirement of the accepted good practice, particularly if your hazards go off-site and can do harm off-site. Yeah. But so what you're doing is using the risk assessment to decide if you need to do more things in addition to what's required in accepted good practice. So if we just look at these three things in a bit more detail, using it positively, not doing a risk assessment on the basis of reducing costs or not doing something, not complying with accepted good practice. For example, let me give you an example. Let's assume your business won a contract to install a high-pressure gas pipeline across the Sahara Desert. Okay, and you decide, oh, we need to do a risk assessment. So we'll have a look at this, and you find, oh, hang on a minute. There's hundreds of kilometers of this pipeline where even if the gas pipeline leaks and it finds a source of ignition and it bursts into flame or explodes, it doesn't do any harm because there's nobody there. And in fact, because the environment is just sand, we don't harm the environment either. So because the level of risk is so low, then what we'll do is we'll make our pipeline out of just getting some dustbins and cutting the bottom off and welding them together. And why not? The risk is so low. Let's save some money and do that. Well, you can't do that because there's pieces of current accepted good practice out there that says if you want to transport natural gas in a high pressure pipeline, then it needs to be a proper pipe made from steel or whatever to certain standards and so on and so forth. Okay, so it's using it positively. It's not using risk assessment to try and not do something, especially not doing something with current accepted good practice. And this is difficult. There's another situation where this becomes difficulty for companies. Many of you will undertake what's called process hazards analyses, maybe every 5 years, where you have a critical look at the processes that you're operating. But of course, the people who are doing these assessments for you, the team of people you get, obviously will look over the history of the plant and think, well, it can't be that bad because it's been operating for the past 30 years. So straight away, they start going into doing this assessment with blinkers on, not being as open-minded as they should be. The very first question they should be asking when they start a process hazard analysis is, if we were building this plant today, how different would it look? Would it? And it's very likely that your existing plant, if you were building it today, wouldn't look very much like the one that you're working with now. So there are potential improvements there, quite simply by looking at current accepted good practice. The other one, not on the basis of convenience. This is how we manage our processes in this organization. This is what we do. Yeah, so a couple of examples there. Many of you will be experts in doing certain processes like chlorinations or phosphonations or whatever. And you'll always chlorinate using liquid chlorine, for example, or gaseous chlorine. Well, of course, there's other ways of chlorinating stuff. You don't necessarily need to use liquid chlorine. It's there now, but if you come up with new products, you'll almost force yourself to look at synthetic routes handling liquid chlorine. And you can see from the business point of view all the drivers there for why that would be useful to do. But it may not be the best thing to do if you were doing it based upon risk, where you'd be applying the control hierarchy appropriately. You'd be looking for inherent safety. Do we actually need to use liquid chlorine? Can we use some other chlorinating agent, and so on and so forth, that significantly reduces the risk? Yeah. So another example I've come across recently is a company that is developing a new process in existing equipment, which of course has a lot of benefits using existing equipment. And the company almost philosophy is our reactors, the basis of safety of our reactors is venting. So the company I've been working with recently, they understand this. They understand that they have to identify the hazards, so they've spent an awful lot of money on chemical reaction hazard assessments. And lo and behold, it's showing that the vent that's on the existing reactor isn't big enough to cope with the runaway reaction or decomposition that could actually occur in this new process. But because the company's decided that venting is the basis of safety, now the vent isn't big enough, well, that's okay. We'll risk assess away. So we'll do the risk assessment to show that this thing is so unlikely that it's very unlikely to happen. It's a common approach, but it's not the correct approach. We should be going back to basics and looking at, well, if that's not the right basis of safety, let's consider some other basis of safety. Let's try and tackle it from inherent safety, prevention, control, and mitigation. Okay, so it's a different philosophy. It's looking for those changes in risk constantly. Proportionate risk assessments, obviously, the greater the level of hazard or risk, the greater of level of detail, the more resources it's going to take to do the job. Okay, got to take account of the performance of the existing process. The design intent may have been sound when it was first designed and built, but if it's an existing process that we're re-HAZOPing or doing the risk assessments on, we need to take account of that performance data, how that plant has been performing. So we need to look at, any metrics that we have on the system, any incidents or near misses that have occurred, any changes in standard, and so on and so forth. Where do we know that it's not as good as it could be? And of course, although when we're trying to assign probabilities of failure of pieces of equipment and so on, which will reduce the level of risk down accordingly on our plants, we need to make sure these days that we fully justify. We know beyond any level of doubt just what the risk is. These days, just falling back on historical data, we really need to justify why that's good enough. It's really trying to get us to get to the point where we have sufficient data of the performance of our own plants. That's difficult, of course, to get that statistical data because our plants haven't been running for long enough to get it. But companies are starting to achieve this. You've got to look for it, you've got to record it, and so on and so forth. So doing the job properly is difficult. We may have, these businesses that have got good policies and procedures for doing these things, that say that we have all of these stages and stage gates and things when we're putting a new product through or a new project through. We may have written down what we have to do to make sure it's robust, but this of course takes an awful lot of effort, a lot of resources, and other aspects of the business can tend to hamper us from doing the right thing, hamper us from actually implementing our own policies and procedures and doing that right job. Many of you, just as my business is, we pride ourselves on being very responsive to the client. Straight away, that puts timescale pressures on us. Yeah, we don't want to tell the client that, well, yes, we can make this product, but it's going to be at least 9 months before we can do it for you, because we need to do this, and this. Okay. So there's time pressures on us. Often there's insufficient project spend allocation. Often, well, I would say almost 99% of cases for new projects, we've determined the level of spend on this project before we've gone anywhere near considering what the level of risk is and the measures that we need to reduce that risk down. As well as having insufficient competent resources available to do this job properly, which you need if you're doing a high proportionality job, i.e. the hazards and risks are large, then, getting a handle on what can go wrong, frequencies, probabilities of failures of equipment, all the rest of it requires a lot of competent resources. And, as you'll be aware, just like in any business, we've been letting our competent resources go over the years through other reasons, impacts on the business. So it's like everything else, nothing happens properly unless we have that commitment from the leadership to do things properly. So all of these things are cultural, It's all right having it written down in our policies and procedures. This is the way we should do it. But people's attitudes and behaviours and what drives those attitudes and behaviours, like being forced to do things too quickly, like being forced to save money, like not having the proper competencies to do it or commitment from the leadership to do the right thing, will all stop us from doing things properly. So a good business that really does have these policies and procedures present, and they know that they're implemented well, and after all, there's been an awful lot of research done over the years that says if we have well implemented policies and procedures that people follow, This is the secret to having good performances in business, not just in health and safety, but in all core elements. Yeah, so we've got to have the pieces of paper, but it's more than that. It's people understanding why they're being asked to do things and actually doing things appropriately and as the policies and procedures are given. So they've got the time to do the job properly. They've got the resources to do the job properly. A few companies I've worked with new projects, final approval has been given to the site manager. And unless that site manager can see the full evidence that they have, that this design, construction of it and everything else has gone through robustly the company's policies and procedures, they will not give final approval to turn that piece of plant on. And they're backed by the senior managers and the leadership for that to be the case. It forces them to do things properly. And a few companies, not many in my experience, the capital spend is not allocated until we've got the final design prepared. We've done our risk assessments on the designs. Our final design is at a level of risk that everybody within the business and everybody interested in our business, all our stakeholders, are happy with that level of risk. And then we'll decide what the spend is to make it that way. It's a difficult thing to do. It's a different way of thinking about things, but some businesses are starting to do it. And all I'm summing up with is we've done the proper job. Yeah. Many of you will have written down what the proper way of doing this is in your policies and procedures. Many of you, if you put hand on your heart, will know that you don't implement those policies and procedures as well as you should do. And it's these cultural attitudes and behaviours that are the thing that needs to be changed, different ways of doing things. So I hope you found that at least thought-provoking. Please think about, honestly, how you do things on your own site, how good or bad you are at doing this. Are you making yourself vulnerable, or have you done the proper job so you can feel that, we've done things proactively? It should be safe. It should take us into the future. It should sustain the business. So I'll finish off there. As always, use our system. If you want to have further discussions with me, or you want us to help you come and work on identifying your hazards or pulling together a risk assessment policy and procedure for you, or working with your teams to develop good practice, changing these behaviours and cultures, then please just get on the phone or send us an email, and I'm sure we can help you make things better for all involved. So as I say, I hope you found it enjoyable. I'm going to sign off now and just wish you all a pleasant weekend, and goodbye to everybody. Bye-bye.